let's discuss one more problem on kinematics, and let's rewrite the equations, which are the three equations which we use in kinematics. And if you recall it properly, they were V final equals V initial plus acceleration T final minus T initial, X final equals X initial plus V initial T plus half acceleration times Tf minus Ti square, and Vf squared equals Vi squared plus 2a X final minus X initial. So these are the three equations which we can always use to solve any problem in kinematics. And the problem is that the Tom starts driving from his home and his initial velocity is 0. He drives, and because he starts driving at initial velocity 0, he presses the gas pedal, and then he does that for 20 seconds with an acceleration of 1 meters per second square. And once he reaches some speed because of this acceleration, he keeps moving with that speed for another 80 seconds, and then he slows down at an acceleration of 2 meters per second square, and he does that for 10 seconds. The question is, what is the final velocity of Tom, and what is the average velocity of Tom? Well, so let's try to find Vf. So now you see this journey has three different sections. This section has a case with constant acceleration, this particular section has the case with constant velocity, and this section also is the case with constant acceleration or deceleration. Well, I should put a negative sign here to make sure that he's slowing down. So acceleration is negative in the positive x direction. That's how you can define your x-axis. Okay, so we really can't solve the problem all in one time, and we have to find different values at different intervals. So let's try finding what is the velocity in here at point 1, point 2. So at 1, what is going to be the initial velocity? For the sake of simplicity, you can assume xi to be 0 and ti again to be 0. Okay, so what is the velocity at 1? And to calculate that, we can use which of these formulas? Well, the first one. So what is the velocity at 1? Let's call it v1 equals, what was the initial velocity for this interval? Well, the initial velocity for this interval was 0 because Tom started with initial velocity of 0. What was the acceleration? Well, it was 1, and Tf is 20. You see, he traveled for 20 seconds minus, we already have assumed Ti to be 0, and that gives us 20 meters per second. Okay, so we are done with up to here. Now he keeps on moving with a constant velocity. As you can see, there is no acceleration in this case. So for 2 also, velocity is 0. Is 20 meters per second. Okay, let's label this 3. What is the velocity at 3? Okay, for 3 we have to consider the section from 2 to 3, and again we have to find the final velocity using the first formula. So what is Vf? Well, V3 or Vf, you can say V3 is, what is Vi? Now Vi is the initial velocity which was at 0.2, because we are talking about this particular section. So it's going to be 20 plus, what is acceleration? It's -2. And how long he traveled? Well, he traveled for 10 seconds. So this time minus this time, which is this particular thing. Don't get confused with these variables. They are just indicative about the final velocity and initial velocity and final time and initial time for some certain section. So these are some generalized equations. These variables do not make sense anything more than that Tf is some final velocity, Ti is some initial velocity. Sorry, Tf is some final time, Ti is some initial time, Vf is some final velocity, and Vi is some initial velocity. And that is true only for some section of time. Like here we have 3 sections. Alright, so multiplied by 10, and that gives us 0. So Tom actually comes back to rest. So the final velocity Vf is Vf or V3, whatever you label it, is 0. Okay, what is the average velocity? Now we know to calculate average velocity we need to calculate net displacement or change in displacement divided by change in time. So what was the net displacement when Tom went from his home to point 3? Well, then we have to calculate the net displacement by adding up all the displacements he made during these 3 sections. So let's calculate how much he traveled in the first section, and which equation are we going to use to calculate that? Well, we have to use the second one. So xf, where by xf we mean x1, that is the distance he traveled, equals xi we already have assumed to be 0, vi is also 0, so 0 plus 0 plus half multiplied by a, which is 1, multiplied by t squared, which is 400, and that gives us 200 meters. Okay, now we have to calculate the distance traveled for this section. Now for this section we can again use this formula, but instead a is 0 in this case, and a is 0. I'm sorry, this should have been Tf minus Ti. In a hurry I wrote T. Okay, so what is the distance traveled in this part? Well, distance traveled in this part, you see, x2 is the distance, final distance for this section, x1 is the initial distance, plus the initial velocity was velocity here, which is same throughout, and that we just calculated to be 20, multiplied by what is Tf? Well, you see Tf minus Ti is actually 80, because we already have mentioned that he traveled for 80 seconds. So it's going to be 80, and that gives us 1600 meters. So x2 turns out to be sorry, this is just 1600, so plus x1, and this turns out to be 1800. Alright, so distance from here to here is 1800. Now let's calculate the distance traveled in the last section, and again we will be using this particular equation to calculate the distance. So what is xf? Xf is actually x3 What is xi? Xi is actually x2. What is vi? Well, vi is actually nothing but 20. And what is tf minus ti? Well, tf is here and ti is here, so tf minus ti we already have mentioned to be 10, so multiplied by 10 plus half at squared, so it's half. And what is a? It's minus 1. And well, tf minus ti squared is going to be, you know, that this is tf and this is ti, so again it's just 10, so it will be 10 squared, and that gives us x3 equals 1800 plus 200 minus 50, and that is how much? 1950 meters. So that is the total distance or displacement Tom traveled from here to here. Now to find the average velocity. Average velocity will be the net displacement, which is 1950, and the total time, which is from here to here. And the total time is 80 plus 20 plus 10, which is going to be 110. And this is something like 195 over 11 meters per second. So the moral of the story is that whenever you have problems like these, break them into different sections, in which we have, like for here in this case, we have constant acceleration, constant velocity, and again constant deceleration. You do not have to solve all the problem in one time. Break it up, and then for each section apply these equations to get different variables at the different intersections.